We'll start or discuss today on engine management system, how the system works or the vehicle control for fuel and emission, all this thing. So this engine management system gives us precise control, right, for the emission, safety, comfort, and dynamic driving, enjoyable driving. So earlier this controls were mechanical side, right? So because of wear and tear, we could not control emissions or safety or comfort. So there is a limitations on these points. But with the help of or introduction of electronics, these units or these 4 points are get more comfortable or more ease of operation for all applications of automotive. Maybe it two-wheeler, four-wheeler, everything. So this is the team. On the left side, there is a sensors, couple of sensors in the photographs I have attached, control unit at a center, and on the other side we have actuators like injector, motor, ignition coil, etc. So this unit or these components will support us to control over the different systems. So we have listed around 10 applications or 10 sensors: crankshaft position sensor, camshaft position sensor, temperature sensor, manifold sensor, total position, mass flow sensor, knock sensor, coolant sensor, lambda sensor, and vehicle speed sensor. So this parameter will take and convert into electrical signals, and based on the electrical signals, we'll control over the fuel ignition timing, so that we get the benefit out of that: reduced vibration, noise, and harshness. First, CKP sensor, crankshaft position sensor required to understand the position or reference mark of cylinder number 1. So we can decide the injection timing, ignition timing. It can be either Hall effect or inductive sensor. In figure, it is showing this mark. So this 7 number is for the top dead center of cylinder number 1. In the graph position, it comes in this area somewhere. So this is the mark of cylinder number 1. So based on this signaling, will allow fuel to enter into the cylinder or the way it had. So sensor is fitted on a crankshaft position somewhere, pulley side, with the help of fixtures, and it allows say 0.3 to 1.8 millimeter air gap in between two substances, sensing element and rotating element. Based on this, it produces signal, and this signals pattern is mentioned in the figure. So based on this, we able to introduce fuel to the engine, ignition or spark to the engine. It requires for the operation of this engine. So very vital information from CKP: piston top position sensor. Second is camshaft position sensor. It is same camshaft Hall effect sensor. It has also got trigger wheel, but in a different way. We saw trigger wheel in the CKP, but it has got some division 60-2, right? One is with a larger gap, rest all is a equal gap. So here we understand, say, a moment of flywheel rotation with a respective angle, and when it comes to 7, we can understand top dead center for cylinder number 1. Here we need to identify only according to number of cylinder. So firing of say 4 cylinder in a designated number 1, 3, 4, 2 firing order, any of this. So this injection timing is required to synchronize with the crankshaft. So while timing is happened, injection timing is done, ignition timing is happened. So fuel is entered, and now with the help of camshaft, we introduced a spark, a right time, right amount of spark, right? So based on this, engine will start operating. Third one is temperature sensor for air. So it represents the density of air. So temperature is on a higher side. We have a lean or we have low density. If we have a low temperature, then we have a high density, right? So based on the information, control unit controls the fuel also or regulates the fuel also, right? It works on a NTC principle, negative temperature coefficient. It mounted on an air filter. So while entering through filter, it is monitored based on a feedback signal, can be controlled or can be monitored. I mean, actuated, regulated. Next one is manifold pressure sensor. So again, in the manifold, inlet manifold for gasoline, there is a butterfly. So after butterfly, the pressure continuously keep dropping. So pressure we have in positive, in positive, in negative. It continuously keep changing. So this MAP sensor has a special silicon membrane. It works or it deforms based on a pressure applied to it, and is change the value of pressure resistive resistors, sensitive resistors. So based on a piezoresistive element, we get the pressure continuously, but the result reaches to ECM is mean effective. So we get the correct value of changing of continuous pressure, and based on this, reducing raw emissions. Indirectly, we control fuel on the correction side. If the signals not received from MSC, we cannot control, or ECM cannot control fuel. A constant rate of fuel is provided, which is waste of fuel. Waste of fuel as well as high in emission. Fuel is not controlled, emission is not controlled. So after MAP, total position sensor, the driver wish at which level it wants to run the vehicle. Idle position, part load position, full load position, no change in position, right? Continue position. So there is a shaft, fitted here on the sensor element. As driver changes the pedal, so the position of pedal with the help of these two wipers, it's a potentiometer. So continuously it gives a position where driver wish to drive. Position identified as a incremental or decremental. Both the side we can get the fuel. The shaft rotation considered as a inflow of oxygen. So if oxygen flow is increased, fuel is increased. Oxygen flow is obstructed, fuel is. So operating this entire range, say starting to WOT. For example, 300 RPM to 6000 RPM. So entire range can be have selection, and based on this requirement, we can provide the mass. This sensor is fitted inside the at the filter element. So after filtering the air, there is a sensing element like this box. So air enters into this channel and got measured, and it came out with the 7 number or air outlet from the flow. So here there is a heating element. So with the help of this air flow, it got reduced in temperature, and because of the resistance changes, it gives us a mass flowing into the cylinder or towards the cylinder. So it's a combination of two elements. One is sensing element of temperature, second sensing element of mass sensor. So based on this input, we can change the calculations. Earlier, we used to have a lambda sensor at the end of, or at a exhaust manifold sensor. Now we have a after air filter, this mass calculation unit. So now ECM can calculate. We have around 40 kg of oxygen, for example. Per cylinder, we have a 10 kg of oxygen. So how much of fuel can be completely burned by this 10 kg of oxygen? So we can immediately correct, and corrected quantity of fuel can be entered into the. There is no chance that ECM oxygen sensor will tell to ECM that rich mixture is coming. Now ECM will control over there. This is right from the beginning. We have an input that we have only 40 kg of oxygen per 10 kg on per cylinder. So we'll allow only that much of fuel to the engine or to the specific cylinder. This is fitted on air filter before intake stream NOx sensor. So this is combustion area, combustion chamber. So this sensor, NOx sensor, is mounted on a cylinder block. So wherever or whenever the combustion happens across the range of cylinder, say we have a 4-cylinder engine, so continuously 1, 3, 4, 2 firing is happening. So this combustion produces the noise, vibrations. So this element, piezoelectric element, receives the vibrations from all 4 cylinders, and if it identifies abnormal, then it tries to reduce the ignition timing. So if we correct something based on this, we can save something on fuel and something on torque requirement. We are getting information via a vibration also. So it is fitted on a block. It works under -40 to 160 degrees centigrade temperature. One thing, 4-number application or 4-number fastening screw or bolt, it is fixed with the torque wrench. If we fit without the torque wrench application or torque wrench usage, this may get over tightened and it may start producing the signal at a normal combustion rate also. So based on this fastening torque, it start producing at a normal level also. It is very difficult to identify what is the problem, where is the problem. So a torque wrench is required to fasten this bolt because the element inside 1 number and 2 number, based on that torque value is get fitted. So caution required to fastening the bolt wherever use. Coolant temperature sensor, it is identifying the coolant temperature. So it is inside the water contents, coolant contents itself. So whatever temperature is there, continuously informing to control unit. So where temperature is low, ECM enriches the fuel. Where temperature is high, ECM reduces the fuel. For example, 30 degree centigrade temperature information is coming to ECM. ECM will enrich the fuel to starting. Once temperature keep increasing, say around 95 degrees centigrade, temperature based on a temperature increase, ECM will reduce the fuel. It has got second option also to start the radiator fan. So at a specific time, say 94 degree, it switch on the radiator fan, and say 84 degree or something, it switches off the. So indirectly we can save on electricity or battery. Unnecessary use of battery also prevented. Lambda sensor, this sensor precisely identifies the residual oxygen in the exhaust. To identify this oxygen level, we use zirconium membrane inside the sensor element to carry out the electrolytic transfer of oxygen ions at a higher temperature. So it starts producing signal around 500 degrees centigrade of temperature, and maximum it can produce 1 voltage. With the help of this graph, we can understand this is the standard where minimum applications or right amount of application is there. This side we have a rich mixture, and this we have a lean mixture. So based on this, the voltage produces. So it comes or signal comes to control unit. It is fitted or located on the exhaust manifold application. Exhaust manifold. In the latest application, it is coming 2 in numbers. One is prior to CATCON, another after the CATCON. Speed sensor or vehicle speed sensor to understand rotation of the wheels or to support ABS, TCS, and stability program control units. So based on this, braking, traction control, or stability control is taking place. It will also support to prevent the wheels blocking or spinning so that vehicle stability and steerability are maintained. So all 4 wheels are having this sensor to understand the rotation of the wheels. Plain road, turning position, left or right, rough road, bumps, ditches on the roads, everything is monitored with the help of VSS, vehicle speed sensor. Also available for at a gearbox level. So if you are on a neutral position or at some gear 1 to 5, that all information also sent to control unit. So if you are driving first gear, you will have a more fuel. If you are driving 5th gear, you will have a less fuel. We discussed around 7 or 8 sensors. Every sensor input, ECM will monitor the position parameters and control the fuel, regulate the fuel. In the conventional applications where carburetors are used, there is no control over the fuel once engine started. So it has got some fixed controls, starting position, acceleration position, pump units, but not every changing of temperature, changing of accelerator pedal, changing of knocking position, not every small information is calculated. But here we are with the help of electronic software program, receive monitoring inputs, regulate or control fuel over the very immediate action. Next, and new in the team, turbocharger sensor or turbocharger speed sensor. So on the shaft there is a wheel. This impeller wheel rotates at a very high speed. So we have a sensor to understand the RPM of the wheel, impeller wheel, without having a through hole. Right, this is the body area, and we have inserted up to this certain level, and there is a wall. After that wall, there is a impeller wheel. So this impeller will keep rotating and we will not lose any pressure. So number is identified. This number will support us to calculate, to stop wherever we require to hold the application. Application means overrunning, because idling RPM you have 1000, then it is considered you have 1 lakh RPM somewhere of this impeller unit. So you are 2000, so it has around 2000. So we have a control around 2.5 lakhs somewhere near to that. We'll try to restrict that by help of a controller. So here we'll identify wherever required, we'll control valve, regulated valve. Based on regulated valve, we can spare some gas pressure onto directly into exhaust pipeline. So we can control the number of. This is the control unit. It's the brain of system. It controls fuel supply. It controls air control. It controls fuel injection. It controls ignition. So due to its scalability and enhanced performance, the control unit is also able to control the exhaust system also, transmission also, and other vehicle functions also, safety related, control related, steerability related. So it is the mastermind, head of the management system, controlling actuators with the help of control unit. So up to this, we have received all information with different parameters, maybe temperature, pressure, RPM, angle, whatever. So now we will evaluate all this information and control over with the help of these actuators. So we have fuel injectors, we have ignition coils, idle speed actuators, force control valve wherever required. Mostly we'll see this unit in the gasoline application itself. And lastly, electronic throttle. This is a fuel injector. It's a kind of a electromechanical device, works on a solenoid principle. It is available at the inlet manifold so that the fuel can be directly entered into manifold before the valve opening. In some application, we have throttle body, above throttle body, but that technology is now not there in the production. After this 21, we will have a GDI, gasoline direct injection. So as good as diesel direct injection, we will have this injector in the piston top. So this works on a different applications. Currently, we have this small unit inject before inlet valve. Second is ignition coils. To start the gasoline engine, we require spark. So this coil support us because we have a 12-volt application. But here we required high amount of power. There is a step-up transformer which allows battery power into high voltage, say 30,000, 40,000, 50,000 at a specific timing. So each cylinder is having one spark plug. Ignite the mixture. To provide spark, we have a one coil each cylinder. And earlier we used to have a single coil and a distributor unit. So this coil will produce sparks and distributor will distribute according to the firing order. But here we have a pencil coil or coil on plug, COP. So this eliminates the cable itself, because of cable there is a lot of problems. So now we don't have cables anymore. Next is idle speed actuator, or whenever we change sudden accelerator pedal, this motor allows air to bypass if butterfly is closed. Butterfly is closed, no air is allowed to enter. So engine will die. So engine keep running. We required oxygen. So with the help of this motor, oxygen will be bypassed through a circuit or a channel, and engine will get oxygen supply. ECM will allow fuel supply, and engine keeps running. It has got two applications. One is stepper application or stepper type motor. Second is rotary type. Rotary type is a new design and more or less it fitted with the maximum numbers. The other earlier one, stepper type, is absolute. This is for application gasoline only. In the tank, fuel gasoline is highly evaporative at a day temperature also. So the gas taken to a chamber called charcoal canister. The moisture of the gas is absorbed by charcoal and other remaining gas will transfer to 5 number or a purge valve. Whenever we switch on the ignition, this will trigger and this gaseous fuel gas is entered into the manifold or the area where it can taken as a fuel after the butterfly valve. So by doing this, we'll save some fuel and will avoid the evaporative emissions. If you release it in the environment, this amount, so it is considered as a pollution. If we use it, it's a kind of a saving. So this canister purge valve is located in between canister and manifold. Electronic throttle. If we having the cruise control, adaptive cruise control, safety systems or stability programs, so the accelerator positions feedback taken into consideration so that we can apply cruise control via or acceleration via button itself available on a steerings or steering wheel. So it can be linked with the systems itself. So that was engine management system. A team of sensor is there to support different inputs parameter. Control unit is there to control or regulate fuel ignition. Based on evaluations, we can control output with the help of different actuators. That was one for gasoline and diesel application both. This is second, or this is a new application, exhaust gas treatment, Euro 6 application. So based on a standard introduced, say 99 or 2000, Euro 1, then 2, then 3, then 4, the standard set by CPCB board, standards based on a European emission standards, based on a driving cycle. So we have BS, it is based on an Indian driving cycle. We introduced around 99-2000. Currently we are at a 2020. So Euro 6. So this was the layout, different applications. Now we are introduced somewhere this red line. So earlier we had different applications. Gradually we changed to Euro 2 or BS2, then BS3, then BS4. Now we introduced from 1st of April Euro 6. What is Euro 6? In also coming time, we have a disruptive technology changes undergoes that is RDE, real-time driving emission. It can be monitored and controlled to make different or stringent reduction in the emission level. So this Euro 4, Euro 1 limits. This is Euro 2. This is Euro 3. This is Euro 4, and this is Euro 6. See, there is a big difference between 4 and 6. 5 is also, 5 is also bypassed. So you can say this red portion is very negligible in compared to other any color. So gradually we came to the area where production of the emissions are reduced. So we have introduced 1st of April 2020 onwards, right, more stricter and more restrictive norms. Models manufactured after 1st April must comply Euro 6 or BS6 norms. So emission 4 and emission 6. Non-methane hydrocarbon, nitrous oxide, carbon monoxide and particulate matter. BS4 and BS6 values given. So major changes you can have 3.4 4 application, 0.4 6 application. Already couple of manufacturers are already implemented this Euro 6 15 or 16 onwards in a phased manner. To achieve this target Euro 6, we require more efficient combustion by means of high pressure. Mostly we have a common rail or CRD applications in diesel vehicles, four-wheeler passenger car, four-wheeler higher application vehicle or heavy duty applications. Because of the high pressure, it improves the fuel atomization and improving the combustion process. So pressure in a common rail application, we have 1600, 1800 bar, 2000 rand and so on. Currently we are applying on 2400 bar pressure. So as you increase the amount of pressure, it gives better atomization. Better atomization results into improved combustion process. By using more refined ultra low sulfur diesel fuel. Low sulfur. So fuel is also modified. One is pressure side, quality improvement of diesel, and is advanced emission control on a emission level. By using sensor actuators in an exhaust system, precisely control it and coordinate with the after treatment. Once exhaust enter into exhaust manifold and then keep on moving to the tail end, there is a couple of sensors and actuators to convert this hazardous gases into non-harmful gases. So we discussed fuel quality play a very important role in meeting the stringent emission regulations. So BS6 fuel or ultra low sulfur fuel is available in Delhi since April 18 to understand the other consequences, and instead of 2020 it is made available in during 18 year from 1st of April. Nationwide availability of BS6 because vehicles can move around anywhere across the sulfur content is a major change from 350 milligram per kilo. We reduced to 10 milligram per Euro 3, Euro 4 and Euro 3, Euro 4 and Euro 6. This is the major change. We have not changed any cetane number or lubricity of the fuel, but the sulfur content is a major portion, major part of it. So what is hazardous or what difference it makes us? So first we'll take water vapor. It's colorless, odorless or harmless, no problem. Carbon dioxide, CO2, colorless, odorless and greenhouse effect. Third one is nitrogen dioxide. It is different in color, but it can cause acid rain. I mean, it's acidic in fumes. So definitely it will create respiratory problem, even cancerous. This is a concern area. Fourth one is hydrocarbon, colorless, greenhouse effect gas, fuel smelling. It can choking and breathing problem. Again, this is a problem. Particulate matter, gray black in color, greenhouse effect gas. It can create pulmonary disease and cancerous. So again, it's a problem area. EM is a carbon dust, flying substance suspended in air. While normal breathing we can take in. So once it enters into lungs, nothing can be done. Carbon monoxide, colorless, odorless greenhouse gas can cause suffocation. Yes, headache and lead to heart disease. So all these four need to attention or a serious attention. It will cause hazardous some health issue over human being. Treatment of this hydrocarbon or CO, carbon monoxide, we can control with the help of DOC, particulate matter with the help of DPF, and last one is with the help of selective catalyst reduction. Target to reduce around 90% nitrous oxide and 50% particulate matter. EGR we were using, we will take some small amount of exhaust gas from the manifold itself or cylinder head itself. We'll cool it down and send it to the inlet manifold. Right here, with the help of fresh entering air or boosting effect, will introduce some small amount of exhaust gas into the fresh air. So this will reduce the entire concentration percentage level. So carbon and vapor is there into the EGA exhaust gas. So it will reduce the heat amount wherever the high temperature is there. So oxygen and nitrogen cannot be react in that area. So the preliminary production of nitrous oxide can be controlled. Right? Initial temperature can be reduced or controlled during the time of combustion. So the flame propagation will little bit delayed, and the temperature where oxygen and nitrogen can be react chemically combined will not taken place. So we are doing this since 1999 in the vehicle applications. Second is diesel oxidation catalyst to reduce CO and HC. CO and HC can be retained in DOC, which can be burned by raising temperature. So with the help of this filter element, we have a departronic system. Departronic is a system where we can inject a fuel in a little bit quantity. Say we have a unit here, injector unit here, not equivalent to cylinder injector. It will allow us to reduce the emission contaminated inside the oxidation catalyst. So whenever required, only this injector will allow the system called departronic system, right? So small amount of fuel injected and this filter can be cleared. So, with the help of diesel oxidation catalyst. Second is particulate matter. For this we'll use this DPF, diesel particulate filter. It's a filter like fuel filter, air filter. It will trap. Here we have gases or particulates, flying substances. Black color dust is there, and here we have some green color. That means the particles, dust particle of carbon, are filtered here or trapped here inside. To understand the clogged area, we have a sensor called partial differential. With the help of this pressure difference, initial and after the filter, we'll come to know what is the clog area. Like this filter will get chopped with the help of some carbon layer. Entire box is filled with the carbon coating. This sensor supports us to understand the area. With the help of this blockage, the pressure drops and this side pressure increases. So this sensor will allow us to operate certain things. So it has got some connections. So to understand, A is larger diameter and B is smaller diameter. So here you cannot exchange or interchange the pipe connections. If we do, we'll have some error area or a peak or signal where we can get the idea where what went wrong, so that we can diagnose based on this information. So in the DPF, we have two regeneration strategies. One is passive, the other is active. Passive is normal driving cycle at the rate of, temperature 400 degrees centigrade. It will start, it will itself by its own. ECM will start regenerating its own. In active application, you require, as I was mentioning, the fuel injector. This is the fuel injector, and very small amount of fuel entered into DOC to clear the area, congestion area. It requires bit high temperature, around 600 degrees centigrade. This will have with the high speed or rate of happening is high. That is why temperature is also high. So with the help of scanning device also you can control this to clear the DPF. This is the entire circuit. This is the departronic circuit. This is the fuel injector fitted here. Right? It is connected to a fuel circuit, fuel tank. So fuel is coming to the circuit. This is the control area, metering unit area. From here, it is entering into the direct exhaust manifold. So with the help of mixture, right? Mixture will allow fuel into DOC in a all area, right? It's a cylindrical application. Like a gas burner, it gives perfect shape to the flame. It will give perfect area to spread across the cylinder. Cylinder means DOC cylinder. Majorly have this application in the trucks and buses. For passenger car and light duty vehicles, we don't require this. So last one, selective catalyst reduction. So here we have a bunch of gases. With the help of CatCon or DOC, we reduced little bit. After DPF also, we have three major pollutants: nitrous oxide, carbon monoxide, carbon dioxide. After the AdBlue injection or dosing, selective work with the nitrogen, water vapor, or carbon dioxide. So these chemical reactions will support us to give clean or very less amount of hazardous gases. These two systems in a combined picture. First, we have departronic, where fuel tank connected to this metering unit and via this injector. So this injector will allow little amount of fuel entry before to DOC for the CO and HC. Then we have a particulate filter, DPF. Lastly, we have a dosing module for AdBlue. There is a tank behind this. So this is AdBlue system. AdBlue tank, a separate tank required. So this AdBlue entered into this with the help of dosing module. It is controlled. So this ammonia liquid controls the chemical reaction or faster rate of chemical reaction to reduce nitrous oxide. So DOC can reduce COHC, DPF can reduce PF, and SCR can reduce nitrous oxide. So all three addressed from engine to after treatment. We have DOC, then DPF, then AdBlue injection, then SCR, then after treatment configuration. These two major units required in the system. One is system control or sensor control module and dosing module. This is fitted in the exhaust system. This is fitted on a fuel dosing tank or AdBlue tank. This is some child part which required to take maintenance because it is open to environment. Exhaust temperature, high exhaust temperature, and vehicles are running in a dusty environment, so dust may get attracted to the unit, right? So couple of O-rings or filter or dust plug can be removed where in case it requires. This is some technical data to understand when can or what type of filter is there, when can filter need to be replaced. This is the main area, main component, AdBlue. you can say aqueous urea solution also. It contains 32.5% of urea and 67.5% of deionized water. So from here onwards, April onwards, whenever we take diesel fuel with the help at a fuel station, we require this AdBlue also checked. If we don't have vehicle, if we don't have a liquid in the tank, there is a system right here mentioned. Engine will not start. I mean, you have empty AdBlue tank, right? And system identifies with the help of level sensor that you have empty tank. So it happens, vehicle will not start because here normally we identify tendency of चलाओ और जुगाड़ mechanism नहीं है तो भी चलेगा. So in this case, they to maintain the strict emission norms, they allowed some system, right? So we need to understand the level maintained in the tank so that we can, right from the beginning of engine, we can enter wherever and what amount of quantity liquid we require, and we can control the emission with the help of AdBlue.
They're asking about when you are looking at the emission characteristics, which is being continuously reduced from the governing bodies, to what extent it will go down, and is it really possible to achieve? This is the question he's asking.
Yeah, we had a couple of trainings for this, and we observed that it is meeting the requirement decided by CPCB. So if we maintain the system, we'll get the results. If we don't maintain the system, that is the problem, and the system will get disturbed. SCR system will get the disturbed. For example, this AdBlue, people will enter diesel or water into the tank. So as a result, you will not get the emissions controlled at the desired level. But we have a vehicle observed that AdBlue is constantly monitored, pure in rich urea and deionized water. That vehicle really emits the emission as mentioned in the criteria.
Okay, there's another question here on this. This question is about hybrid electric vehicles. Can you just throw light on this? They're asking.
Hybrid vehicle, there are a couple of OEMs are manufacturing, but in case this emission control system and hybrid, so there is a big cost involved into that. So it may come and it is there in the existence. Say Toyota has a couple of models, but they are high in initial cost. So it can be a option also. Cost will go high.
There is a question from Prasanjit Mukherjee. He asked whether V6 engine can be operated with very low fuel quality.
It can, but the emission will not meet. If you use BS4 fuel in BS6 application, so you will get BS4 emissions, I mean higher emissions.
So naturally that if the fuel quality is not good, the emissions will be higher.
Correct, yes.
Though the engine has a technology to have a better emission control, having a low fuel quality will have that.
Yes, fuel plays a very vital role into this combustion process.
And Abhinav is asking a question. Why are we not switching to vehicles having hydrogen internal combustion engine vehicles that is having almost zero emission?
It will take some time. Immediate shifting is not, I think, a good idea. It will come into maybe after the say couple of years or couple of decades.
The production of hydrogen is very expensive. Basically, if you say that hydrogen is produced by electrolysis of water, then it is actually completely negative oriented approach. Basically, because electricity is having a higher quality of energy compared to the energy what you get from IC engine.
Cost is very high.
Cost is very high, and second part is actually the safety concern is also to be taken care of.
I think I understand from resources, Netherlands is working with this project, and they are coupling. I mean, having couple of vehicles on road, but cost is very high.
The question is, if you try to look at the ECU nowadays coming through. Now, suppose something happens to our car, we can't take it to the roadside mechanic. We need to actually push it to a high-tech garage. And from there, actually, the technical person will plug in his laptop and try to find out where something has gone wrong and completely remove. So what do you feel about it, sir?
Yeah, but this kind of a problem will not appear suddenly. The malfunction indication lamp will give you as a symptom prior to problem appear in front of you. So
Okay.
you will have an indication, say something is wrong with the electronic circuit or some mechanical failure cannot be identified with the system, sensors, ECM and actuator. But if something happening with the help of signaling pattern, this malfunction light flickering at your instrumental cluster. So you will have to know, come to know that I am facing some problem. So rather to direct go on a highway, I can just go through my vehicle garage. He will rectify the problem and then I will go to highway.
How can Bosch help students in the institution? In what way you will be helpful to us? They're asking.
We are conducting various courses on a skill base for a diagnosis, as you mentioned, on a scanner. So we have a scanning device and diagnostic software to understand vehicle live data and program pattern. With the help of oscilloscope also, we can diagnose the problem, signaling pattern malfunction, and we can understand, because nowadays every company, even two-wheeler also is having scanning devices to understand the problem. Earlier we used to trial and error method, but now trial and error method is not allowed, or nobody wants their expensive vehicle to get tampered. This kind of and entire system oriented courses also there to upgrade themselves with the align with their studies, so they can understand what is the current scenario in the field and they can upgrade themselves, groom themselves.